And if you are sleeping, then sleep and the other will do for you. But when the other do for you, then you will have to give the price. Da goye shi de pa mugi bandi waladi. Da goye ni aw da zamidar garib wala baran ke mandi hui o waha wala raja maki kana. Ha? Kuch kale pa ye vitadi. Da goye warta bya inkar koni shi. Aw shi halali ye. Halali ye chata goye bhi nahi jama mal ala hai. America che dar sarar se pin wala borta hai. Zaka che agidar lagarti hota se pray. Right? So it is up to you. If you are talented enough, if you are excelling, then you will be the leader of the world and you will decide the norms of the world. But if you are sleeping and others are earning for you, then you will have to accept every of their norm. We are really fortunate that we are in an age where everything is possible. If you ask your elders, your teacher, and if somebody would have told them that in 30 years you will have electron microscopes in Peshawar, people would have called us mad. It was impossible. I didn't see any XRD, any electron microscope, any fine processing unit for materials throughout Pakistan when I was going for my PhD. Secondly, there used to be a person or two in the whole country who used to see the research publication. And chicha sarapa asim naga the research publication o khalak bachi rustu karte the uchata sam na kafir bache udra ka bache da usmara ali. Right? Now everything is at your fingertips. So there is no excuse. Bakka moras che mnashe au khudai ta makh takine nulumbe goguna badar bani padi nisi che wole da arsamata su da darkadi nu che khalqu kul na tasu saku lumbe. This is the best region in mineral wealth, in water resources, fertility of the land. You are born in the best piece of earth. It is up to you when you go to the individual atoms of the material within your country, within your resources, and you can do everything. What happens to the material? I'm just giving you glimpses. This is a quartz grain. This is a porcelain material. Porcelain material means alkali aluminosilicate composition of glass. In the middle you have a quartz grain. When you heat it up beyond a certain temperature, for example about 1200 roundabout, the glass melting starts, the quartz melting starts in the vicinity of the alkali ions. Otherwise quartz need nearly 1800 to 2000 degrees centigrade temperature. But if it is in the vicinity of other alkali cations, it easily melts. Che doruna yo plastic ke plastic galite pasane hui kuch yo pa ke plastic reti nishi. This is the same thing. The reaction, what is the reaction? It is the loosening, the breaking of the atoms. If an atom can be broken easily, the reaction will occur easily. If the atom cannot be broken easily, the reaction will not occur easily. The positive cation is pulling out oxygen from the material. If the one which is forming the phase and other alkali cation is additionally there, the pulling will increase. When that pulling of oxygen out of the material is increased, and at the same time you heat treat the material, that quartz which used to be melting at 2000 degrees Celsius is now melting at 1200 degrees. So you can change the melting temperature, the crystallization temperature, but take care of the thermal expansion coefficient mismatch. If the thermal expansion coefficient of one material is different than the other, the one will try to expand more and the other will not expand that much. So what will happen? The weaker will break, right? It will be squeezed, and if it is brittle, it will break. So, the prehistoric man made ceramic, but ceramic is equally important today. For example, uses of agitator or agitator ball mill to decrease the particle size more than 20 times. Marble sawdust, which is polluting our springs throughout the country, it can be utilized as a fluxing material in porcelain. Utilization of million tons of waste glass in ceramic industry is a better thing to avoid environmental pollutions. Immobilization and volume reduction of radioactive waste, because it is the best way to decrease the volume of radioactive waste and make vitreous ceramics from them. Fluxing additives, lower sintering temperature, new smart dental materials, biomaterials, soft bones, human history. And as I told you, that 2000 years ago, the Chinese invented the white gold. او دا هغه سړي چې چا سره به سپین پلیټ و نو دومره نشه به وه چې چا سره بیا خبرې هم نه کوي. It was that. Now come to the electric world, the polarization world. دا هغه لینده ده ماشومان چې پې مرغۍ ولي. Right? When it is loose, it has no capability to do work. When it is pulled, this means you have stored energy in it, and whenever it is released, it will do work. The same thing is with the atom. If atom is neutral, the center of mass and the center of charge are coinciding, it has no ability to do work. But if the center of mass and the center of charge are slightly displaced, it is called polarized atom. And the whole game of the modern world electronic devices is based on that Rakhkali Lindo. Right? You polarize the material and you store energy in it, and then you utilize it, and it has led to the development of that cell phone. Right? How simple it is. This is so simple, right? But think about it, adopt it, accept it as a culture. The old man learned to use the clay. The modern man took it to the insulating transformer cores, insulating electrical components, and many modern products, because he learned to sinter clay flux plus quartz at economical temperature. The modern man, as I told you, they needed a portable device with minimum loss and with no change in operational frequency. They needed a high dielectric constant, close to zero temperature coefficient of resonant frequency, and minimum loss, and they are looking into the material that where these properties are present. So you take the fagwali the para chini wali, the trakwali the para che wali, the anti-acid patoga bane pe wali, or you make a cup of tea. It is acceptable to you and it is useful for you. Similarly, you look into dielectric constant, you look into the quality factor, and you look into the various properties you are looking for, and you combine them into the material, and you get something from there, and then they have the complexion of all the properties you need. When I did all these, I found this. The dielectric constant actually is speaking like this at the Curie temperature. But when I played with it, I got a straight line. So, this is very useful material. because that material can be only used at that particular temperature where the dielectric constant is peaking. But when you have a smooth line, it is not coming down. This means you can use the material at high temperature as well. For example, if the capacitor is required for a car engine, then you will have to work at high temperatures. Okay, Mr. Charo, where was the problem? It has a good dielectric constant, it had a good ER and temperature coefficient of resonance frequency, but very poor quality factor. From where does the quality factor comes? It is the unit cell of the crystal. If the cations have minimum space to move around, listen to it carefully. If the cation, assume that the unit cell is a small box. Unit cell is a small box and you have cations and anions inside that box. If you give more room for oscillation will lead to higher polarization. Higher the polarization, large will be the polarizability. Larger the polarizability, higher will be the dielectric constant. So for that you need an open space for the cation to move around. But more the oscillation is, more the power dissipation will be there. The more the power dissipation, the more will be the loss. The more the loss, the poor will be the quality factor, and your signal will be lost in the middle. Right? When I found this, then I tried to look into it, that what is happening here. I look into the microstructure. The microstructure was apparently two-phase. When a second phase is there, it is just like that when you connect Torbella Dam to your center of excellence and you get a 200 kilometer wire coming from there to here, but a small piece of rope is there. 1 millimeter, 2 millimeter, 10 millimeter, will it conduct? No. You need dielectric constant, and for the dielectric constant you need the specific crystalline phase. If you put another phase in the middle, what will happen? It will decrease that quality. So second phase formation always leads to the increase in losses, and to avoid that